The interstellar wanderer has returned, brighter, sharper, and more mysterious than before. Its glow cuts through the endless blackness like a silent message from a distant world. It moves with an eerie grace, drifting through the void as if carrying the forgotten memories of another sun. Behind it trails a luminous path of frozen dust, a cosmic signature written across the heavens. The idea that something from another star system could collide with Mars feels unreal. It challenges our belief that our solar system is calm and predictable. Comets were once viewed as harmless wanderers, beautiful but irrelevant. But this one, this silent traveler, feels different. It radiates intent, speed, and something that almost resembles purpose. When the first faint reading appeared, astronomers across the world dropped everything. Telescopes swiveled. Calculations were redone. Models updated. And slowly, the truth came into focus. This object might not simply pass by, it might strike Mars. Forged in the icy nursery of a distant star, this traveler has spent ages drifting through interstellar space. Now, after uncountable years of wandering, it has arrived in our solar system on a path that seems frighteningly aligned with the orbit of the red planet. It feels like a cosmic chapter unfolding, a collision scripted by the universe itself. This object, 3I, Atlas, is only the third confirmed interstellar visitor after Oumuamua and 2I, Borisov. Yet even among these rare messengers, 3I, Atlas stands apart. Its orbit is unmistakably hyperbolic, meaning it was never bound to our Sun. It is a true outsider, traveling from regions of space we can only imagine. Infrared observations from the James Webb Space Telescope reveal a coma filled with carbon dioxide but lacking water ice, evidence that it formed in a much colder, more distant star system. As it approaches the Sun, its trajectory aligns almost perfectly with the orbital plane of the planets. Instead of drifting by harmlessly, it cuts dangerously close to Mars' orbit. Each new update shortens the distance. Webb's instruments track every flicker, every release of gas from its frozen surface, tiny bursts capable of altering its path. But even with these unpredictable shifts, the probability of an impact continues to rise. If 3I, Atlas collides with Mars, it would be the first recorded impact between a planet in our solar system and an object born around another star. The scale of such an event is unimaginable. Mars, home to rovers, orbiters, and humanity's future dreams, could face a blow powerful enough to reshape both its surface and its sky. Imagine it. A frozen giant slamming into Mars at tens of kilometers per second, unleashing energy no human has ever witnessed. A crater carved into the red desert. Shockwaves trembling through the thin atmosphere. Dust clouds rising high enough to darken the sky. And within that destruction, opportunity. A collision would scatter fragments of another star system across Mars, alien material delivered directly to a planetary surface. Scientists would rush to examine the crater, the debris, the atmospheric changes. A nearby rover could even capture the flash of impact, a brief, brilliant moment marking the meeting of two worlds. But the danger is real. Orbiters could be damaged by debris. Rovers might be showered with fragments. Even smaller pieces could trigger secondary impacts across the surface. As the possibility becomes more certain, observatories worldwide shift into high alert. Telescopes in every hemisphere lock onto the same faint object. Data pours in from Chile, Hawaii, and space-based observatories. NASA, ESA, and JAXA remain in constant communication. Every new calculation whispers the same unsettling conclusion: the comet's path continues to converge with Mars. Webb's readings show jets of gas erupting from beneath the crust, subtle bursts that nudge its motion ever so slightly. But even these unpredictable movements have not guaranteed a safe passage. Whether it hits or misses, this moment is historic. If it impacts, humanity will witness interstellar matter striking a planet for the very first time. Seismic sensors could record the vibrations racing through Mars' crust. Orbiting spacecraft would capture the flash, the plume of dust, the shockwaves drifting into the thin air. If 3I-ATLAS misses Mars, scientists still gain an extraordinary and unprecedented gift, an opportunity to directly observe interstellar matter as it passes through our solar system. These fleeting fragments, made of alien gases, icy particles, and complex organic molecules, offer a window into the chemistry of distant worlds. Each molecule, each particle tells a story billions of years in the making, stories of formation around distant stars, of icy planets orbiting suns long gone, of organic precursors drifting across the void. Some of this material might even find its way into Mars' thin atmosphere, subtly altering its chemical balance and leaving traces for future missions to discover. Such an event would be the first time humanity has witnessed the raw ingredients of another solar system interacting with our own planet in real time, a cosmic handshake across light years. Engineers and mission planners are preparing for every possibility. Mars orbiters are being repositioned to avoid potential debris, solar panels angled for protection, instruments calibrated for maximum data collection. Rovers on the surface may enter safe mode, awaiting instructions from Earth, ready to observe anything unusual. Every adjustment is a careful dance, balancing the quest for knowledge with the safety of decades of robotic explorers. It is a reminder that science, at its heart, is an intricate interplay of precision, risk, and discovery. But beneath all the technical planning and calculations lies something profoundly human: awe. Wonder at the sheer scale of the universe. Wonder that we, a small species on a tiny planet, are alive to witness such a cosmic event. For centuries, humanity has searched the skies, hoping to uncover our place in the vastness of space. We have sent probes to distant planets, telescopes to the edge of observable space, listening for whispers from the stars. Now, the universe has sent a messenger not through sound or light, but through motion, a silent traveler carrying the secrets of another star system directly into our solar system. 3I-ATLAS may be more than a frozen rock. Its composition could contain compounds older than our Sun itself. Carbon chains, amino acid precursors, fragments of planetary crust from worlds we have never seen, everything it carries is a message from the cosmos. If even a fraction of this material survives near Mars, future explorers may uncover crystals, complex molecules, or chemical fingerprints that Earth's laboratories have never synthesized. This is not just a scientific opportunity. It is a reminder that the building blocks of life are not bound to any single solar system. They drift freely, scattered across the galaxy, waiting for the chance to seed new worlds. Whether the comet strikes Mars or passes safely by, it will leave an indelible mark on how we study the universe. Humanity is no longer just an observer of interstellar matter. We are participants in its journey. The measurements, the data, the observations, all will redefine our understanding of how matter, life, and planets interact on a galactic scale. The world waits with bated breath as telescopes track its every motion, as satellites record every flicker of light, as instruments on Earth and in orbit capture the subtle signals emitted by this alien traveler. Every hour brings us closer to the encounter, every calculation narrowing the uncertainty, every update a reminder of how small yet connected we are in the vast cosmos. Somewhere far beyond our planet, in the silent, frozen emptiness, 3I-ATLAS races onward. Its icy surface reflects the sunlight of our star, while jets of gas vent into space like the faint breath of a sleeping giant. Within weeks, it will reach the orbit of Mars. And whether it grazes the planet, showering it with fragments, or collides in a dramatic explosion, the event will resonate across space and time, a stark illustration of the delicate balance of creation and destruction that governs the cosmos. And when the dust finally settles, when the orbiters and rovers report back, perhaps we will finally understand something profound. The universe has never been silent. It has always been sending messages, weaving stories, orchestrating encounters. And for the first time, humanity may be listening not just with instruments, but with wonder in our hearts, eyes fixed on the heavens, and minds open to the possibility that we are connected to the stars in ways we have only just begun to comprehend.